Hey everybody. My name is Ben Goosman. I am a senior software engineer at Kineviz. I've been working for the past year on AI automated document analysis. And today we're going to go over a visualization first approach to generative AI and knowledge graphs. Feel free to throw any questions in the chat and I'll try to get to those. But yeah, let's get started. So why visualization, knowledge graphs, and GenAI? A couple of reasons. Visualizations reduce overwhelm. So for me, looking at link charts or network graphs or knowledge maps or knowledge graphs, however you want to call them, looks a little simpler, less overwhelming than looking at a massive pile of text. Don't know what's important or what you should look at first. It helps condense information into bite-sized chunks, and they encode information into visualizations, but they're time-intensive to make by hand. Generative AI helps us make knowledge graphs automatically. So what are we generating? Or what are we in the business of generating? So we start with text, and we ask the AI, I'm interested in relationships between persons, organizations, locations, and events. And out of the AI, or a large language model, comes, we could think of them as triplets. Alice knew Bob from high school, and Bob. We would call Alice and Bob persons, and Alice knew Bob from high school being the observation. That becomes the graph. So we build a whole tool at Kineviz for doing this automatically. We're calling it SiteXR. And here's a little flow chart of how it all works. So we take a document, like a news article, this one being about insurance fraud, and we send it through Apache Tika to get text, and we apply some magic with local or cloud language models, and out of that we get a knowledge map and an index of all of the document text, entities, and observations. I'm going to say the word knowledge map a lot. We're calling it a knowledge map instead of a knowledge graph because knowledge graph tends to apply some exact representation of the world, whereas the knowledge map is more about stating interesting things about entities and the relationships between them. Those statements we call observations, and the entities are things like persons, organizations, locations, and events. We'll visualize that in GraphXR, another tool created by Kineviz for graph visualization. And we will also be able to chat with our document using SiteXR. Just to mention some technologies, we use Neo4j for the database, Quadrant for the vector database. So to start, this is SiteXR showing our imported PDF. Staged car crashes in the family that pocketed $6 million. This is a true story about a guy named Bill Mize who would stage car crashes, injuries to get hospital visits, insurance payments, a bunch of illegal things to make a lot of money. He did make a lot of money and eventually got caught. But we'll use SiteXR to get a sense of his world. So this is a screenshot of the knowledge map. You can see some clusters of nodes, the observations being in yellow, and all of the other ones are entities. And I'll pull that up live. So this is the live view of our knowledge map. Let's look at an example. Here's an observation. Sandy acted as the licensed real estate agent for Mize's property flipping. That observation is connected to licensed real estate agent and Sandy. The clustering helps us identify connections, and also the number of statements being made indicates the importance of, or relative importance of entities. Like this person at the center is probably pretty important, and it happens to be Mize himself. A screenshot of Mize, which we were just looking at, and on the left-hand side, the observations connected to him. So if we go back to SiteXR, we can find Bill Mize right here. And see all of the related things to Mize, like persons, events, locations, and organizations, sorted by the number of times they were connected to him via observations. So between Bill Mize and Angela, there were 24 observations being made. And we can click on these items to quickly expand through the graph, like a website. So I'll go back. And what I wanted to show was that this list of observations is what we were seeing in the screenshot before. This is all the list of observations connected to Bill Mize. So this helps reduce overwhelm by providing a summarized list of key facts about important entities. And on the left-hand side and on the right-hand side, the spatiality of the graph helps cluster things together that are important and have a lot of connections to each other.
Ben, can I ask a question real quick? Can you
Yes.
restate like what the observations are doing a little bit?
Yeah.
Yeah, we actually got the same question in the chat from Laura. Thank you. How do you determine an observation?
Good question. So let's pick one. So this one says, I'll make the text a little bigger.
Thank you.
After crashes, Mize would direct victims to request certain antidepressants and painkillers and hand them over to him. That's the observation. It's made about two entities, which happen to be persons, Mize and victims. So the magic we're performing is using the language model to identify these observations and the persons that they're connected to. So we feed in document text plus the prompt, which is find all the relationships between persons, organizations, locations, and events. And the output is structured data that we parse and convert into these observations. So for every observation, there's going to be two things connected to it, the entities that are involved with that observation.
And also you can cite where it came from, correct?
Exactly. So its dimensions, we call them, are listed underneath sources. So if you clicked on this, it would open the document text for this PDF.
Cool. Thank you. Keep the questions coming. Thank you.
Um, right, so there's a lot in this graph, and it's easy to get overwhelmed even in this chart. So a helpful thing to do is highlight stuff you're interested in and unhighlight the rest. So let's center to this observation and try to trace neighbor on it. Let's search for it. It is this one here. We'll trace neighbor 1, and this highlights that observation and the fact that victims and mice are connected to it.
We have another question. Can you assign importance to the observations through color or density of line, like density of the relationship, for example?
Mm, um, we don't measure importance of observations. It using typically you would map something like the degree of a node to size or color. But for every observation, the degree is going to be 2 because it's connected to 2 entities. So that mapping would be meaningless. Um, it could be interesting to do a centrality measure, like, I don't know, I haven't tried this yet, but maybe page rank or betweenness. Let's see what that does to our observations. Right, so not very helpful because this guy here has such a high page rank, he completely dominates the rest of the nodes. So maybe
But
some,
the shortcut will show you the direct connection, and then from there you can pull the observations. Because the shortcut, if you can explain that a little bit, um, it sort of bypasses the observation in the graph.
yeah, we can go over that. So you could call this the observation graph, where the observations are inside. And the other form is the related to graph, or the shortcut graph. This is without any of the observations, and it shows you the direct connections between any 2 entities. And we'll go over mapping centrality of these nodes to color and size shortly. But yeah, but to answer your question about observations, not sure yet. But maybe by assessing the importance of the entities connected to the observations, we could assess the importance of the observations themselves. All right. So I went over trace neighbor, highlighting things in the graph in your visualization and unhighlighting other things can make it clear, reduce overwhelm. Okay, great. Now we're getting to um, PageRank. So we can map nodes to color, and we can map the PageRank to color and make things with high PageRank brighter and things with low PageRank uh, dimmer. And that's what I did in this screenshot. Is you can see Mize is pretty bright. He's at the center of things, and some other players are like William Mize the fourth, who happens to be Bill Mize himself. It's the same person, just named differently. William Mize the fifth and Ron Wells. Let's try to get that live. So we have our shortcut graph, and we'll run the PageRank algorithm. let me just start over. Pull these nodes again, and then we'll switch to related to and run PageRank. So yeah, this is what we were looking at in the screenshot with slightly different layout. But the goal is to look for things that are green and white, and all of the very dim blue ones are not important at all for this measure. So there's one down here, Mercedes E500. It is connected to Sebring and Angela, so they had something to do with this. And what else can we see? Licensed real estate agent, Baja Speedboat. And Mike and Sandy, Mize and Sandy. So we can take this text and try to find out more about it. I'm going to go back to the observation graph, and we can see the Sebring was driven towards a waiting Mercedes E500 during the criminal activity. Oh my. And I'm wondering if we can even expand here. See if that's working. So I'm wanting to know where that observation came from. So I'm expanding to that node in our graph database. And we can see these two nodes appeared. Chunk. Right, so this is all the document text about Angela and the E500. Looks like they staged a car crash, probably. It said later, Mize told Angela that she'd done well. Oh yeah, Mize accelerated her Sebring toward awaiting a Mercedes E500, feeling she'd crossed some criminal Rubicon. All right, that's PageRank and color, but also node size. So if we map person PageRank to node size, we can see some nodes are bigger than others. It's a little hard to tell, but looks like this guy and this guy are important. Anyway, the point is node size and color can be useful indicators of importance. Ooh, let's go to the chat. Let's do some retrieval of information. Let's clear our graph. So what if you want to know something about your documents? We can type a query here. I used why is Ryan afraid of mice? And it's nice to look at all of the relevant context here as text, but we're in the business of visualization. So let's pull in these observations into our graph. So what I did was I pulled all of this context 1 through 15 and applied a ring layout. to create some nice separation. We can make it even better. So this looks a little less, this looks a little more digestible than, just reading these one by one. Even though both strategies are very helpful, it's nice to have options. And likewise, we can pull the shortcut and see these connections, useful for network analysis. And finally, we can ask the AI for a little extra help here. So right now it's summarizing all of the context and pointing out or identifying useful information. So the summary is here. This is a condensed version of our context. And the way we do that is by just dumping all of the text into a single AI prompt and asking it to summarize it. Pretty simple. And the second part here is identification of useful context. So the way we do that is by, again, dumping in all of our context into a prompt and also adding in the query. So why is Ryan afraid of mice? Plus all of the observations we generated before in our knowledge map. So we're building on our work earlier to create useful insights. And in the text here, it's trying to answer how do you arrive, or how would you answer the question using the context? It's not trying to give you an answer. So we're so used to ChatGPT asking and expecting a result, and that's great. But if you're in document analysis mode, if you're in a law investigation, any domain, often it's just enough to get to the relevant information and make a conclusion yourself. The AI is prone to hallucinate answers. If you give it insufficient context, then it's just going to make up an answer that fits your context. It's going to overfit that context to give you an answer. We don't want that. That removes trust in your AI system, your Q&A, and once you lose trust, you've lost. So we're in the business of identifying useful things. And with the help of our in-text citations, we can jump directly to the information used in the AI-generated answer. Like this one. Ryan describes himself as Mises' minion and mentions that Mises' whims constricted his life. Let's see. This is a screenshot of the related to or shortcut portion of the graph. And I think that's all I wanted to show about visualizing things using AI in the context of document analysis. So let me make sure I didn't miss anything. Oh yeah, okay, great. Thanks for listening. You can feel free to contact me with any questions at ben@kineviz.com or throw them in the chat. I'm happy to answer and stick around.